Okay, so today we're going to be covering the law of sines, which is in chapter 8.1 of your book. But how much do you all really remember about trigonometry? So we're going to do a poll to see how much you guys remember. So do you only remember how to calculate the trigonometric equations? Do you remember the names but not the functions? Or what on earth am I talking about? So if you guys could just text whichever answer you feel most relates, and we shall see. That's so cool.
I think I said mine.
Okay. Well, we're going to assume that you all said what. Alright, so we'll just start at something that's a little bit more relevant to trigonometry. This is the Pythagorean theorem. You guys might remember it as being a squared plus b squared equals c squared, which is the smaller size. What you would do is you would possibly not have a, and therefore you would plug in the number b or whatever b would be and c in order to find the length of a. So that's the Pythagorean theorem, and that links directly to trigonometry. You guys might recognize this from SATs or previous pre-calc classes, whatever you guys have taken. There's sine, cosine, tangent, and then the more advanced is cotangent, secant, and cosecant. Today we're going to be talking about sine and its log. Alright, but first we're going to talk about the triangles and ways that you can apply the law of sines. So there are two types of triangles that you would be presented with hypothetically when you get a law of sine problem. And that would be either the two-angle one-side triangle, which in this it would be the two angles, capital A and capital C, and then the one side, which is the lower c. And those would be numbers, this would be degrees, and then this would be a length. And then we also have the two-side one angle, which is pretty much the opposite. You would be presented with only one angle and then two sides to solve the problem. So here is the law of sines. It has the angle of one corner, I guess, of the triangle, and over the opposite length of the triangle. So all of these are, in a sense, congruent. So A would be equal to the B, and then also the C, all in congruency. And let's do an example. Okay, so I'll just write the equation on the board, and it was A over sine A equals B over sine B, which equals C over sine C. So can anyone tell me what the angle would be, or the amount of the angle would be if we were to use this triangle as the only angle that's there?
49 degrees.
Okay. So that we would plug into this A. So we can do, yeah, A over sine of 49 degrees, which is equal to which side is given, like which number of the sides equals the sine of 49, which would give you an actual number, times 5. And then in order to find what A would be, you would divide that by sine B on both sides. Okay, real world application. I know most of you don't like math or think it applies to some, well, most of the time your math teacher gives you something, you don't ever see it again until it pops up in the test. So, alright, so what type of triangle is this? Alright, I guess I should point the numbers first. These are both angles, because they're kind of hard to see. So would it be a 2-angle one side, 2-sided angle? What type of triangle? 2-angle side. Yeah, okay. So since we have the 2 angles, it would be the sine of, we can use 32 first, over the number, to do that is A, and then sine of 74, which is the other triangle, and then the number opposite of 74 is what? Awesome. Good job. So with this, just like the previous example, we will just cross multiply in order to find out what the length of A is, so that we can save Dr. King. So the sine of 32 times 9 equals the sine of 74 times A. And then to get A by itself, we would just divide both sides by the sine of 74.